In this video, I'll teach you how to generate sound from scratch using JavaScript and the WebAudio API. First, I'll show you how to make a beeping noise, which we can play at different frequencies. And then how to generate this engine noise. You can use these in any project you like, but at the end of the video, I'll show you how to integrate them in our racing game with self-driving cars. We'll use the beeps during the countdown timer, like so. And the engine noise is there when driving. We'll make it sound differently depending on what the car does in the game. Now get ready for some sound advice. Get it? Because we'll generate sound. No.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
I have Visual Studio Code open in an empty folder, and let's create our index.html file and start typing basic HTML. The doc type and the HTML start and ending tags. And then in the head section, let's just say the title will be audio effects. Now the body is going to be empty for now. And let's just save and open this in the browser to see if it works. And it does. You can see here the title appearing in the tab. Now let's go back in the body and add the script tag. So this is where we will be typing our JavaScript in this small project. And let's get a reference to the WebAudioAPI audio context. This will be audio context is equal to a new audio context like this. Now, for compatibility with more browsers, we can wrap this in a parenthesis like so. And also look to see in the WebKit audio context. This is important for Safari at least. Let me move this down so it looks better. And now we can use this audio context to define an oscillator. Using the audio context create oscillator method, and we'll connect this oscillator to the audio context destination, which means the speakers usually, so that we can hear it. And let's start this oscillator. Now save this, refresh, and you can't really hear anything yet. If you open the developer tools, you'll see that we are getting an error, a warning actually. It says that a user gesture should happen before starting the audio context. So let's wrap this in a function, and we'll first make a beeping sound. So let's call this beep like so, and wrap everything in it. And now pass it here as a callback to a click event listener on the window, so that when we click on the page, we get the beep. Save and refresh, and the warnings are not there, but we can't hear anything unless we click. I refreshed now so that you can hear me, but basically that's what you get when you define an oscillator with default frequency. To understand better what this oscillator is, we are gonna visualize it on a canvas. So let's add to the body a canvas element. Let's give it an ID of my canvas, and I'm gonna give it a solid border so that we see it there, otherwise it's transparent. Let's also close this canvas tag like this. And in the script at the very top, we are going to get a reference to the canvas drawing context, the 2D context. And let's define an analyzer. This is going to be an object that we use to understand what this oscillator is. At the end of this beep function here, we are going to say that the analyzer is equal to audio context create analyzer, and we will connect the oscillator to this analyzer as well so that it gets data from it. And now we have to make an animation loop, maybe here, where we visualize the data using that analyzer. So let's call animate like this, and the animate function, we can define it just below. Usually, when animating, we clear the canvas first because it's going to loop and we need a clean canvas each time. So let's clear the rectangle from the top left 0, 0 with the width of the canvas width and the canvas height here, the full canvas. And if we have an analyzer, if it's not null, we prepare a data array here. And we're gonna do that by saying data is equal to a new unsigned int array. And we pass here analyzer FFT size. I will explain what this FFT size is, but this uint8 array is just an array with unsigned integers in it, and they each have 8 bits. So unsigned means just positive values. So between 0 and 255. Now at the moment it's empty, and we can put data in it by saying analyzer get byte time domain data and passing the data here as a parameter. This is going to populate it. And now we can use this data to draw a line chart. Let's begin path and loop through the data from 0 all the way to the data length, like so. We need an x value, and I'm just going to get it relative to I and the width of the canvas. So let's just say here this. So I divided by data length gives us a %, and we multiply by this so that we scale on the full size of the canvas. And the y is just going to be data of I. Now we have to check here if it's the first point. If I is 0, then we are going to do a move to xy. Otherwise, we do align to xy like this. And let's go down here and stroke. Now this is supposed to loop many times per second. And to have it do that, we have to type request animation frame animate. And this is our animate function here. Let's save, refresh, and now when we click, I've muted the page so that you can hopefully hear me. And this is actually supposed to be symmetric, but this canvas is too small vertically. Let's make it bigger. Here, where we define the canvas, I'm just going to move this down and let's say a width of 1000 and a height of 255. Let me know in the comments why you think I use this value. Save, refresh, and this is now how that sound looks like. You can't hear it because I've muted the page, but you can see that it's a periodic motion happening here. And you can get different shapes by changing the frequency of the oscillator. So for example, here where we define the oscillator, you can also say that the oscillator frequency set value at time, and the value will be 100, and the time we just use 0, which means now. Let's save this, refresh, and click, you see this is much wider now. And if I unmute, you can hear it was different. It was a lower pitch. Let me explain also what this FFT size here is. And we can set different values for it here. We can say analyzer FFT size is equal to, and they need to be powers of 2. So let's say 2 to the power 15. This is the maximum, I think. Save, refresh, and click. And you see, it looks like it's more compressed, but we haven't changed the frequency. It's just using a larger window size to sample the data. The name FFT stands for Fast Fourier Transform, and here it doesn't really make much sense because we are working with time domain, not the frequency domain, but it just means the size of the window. So if you're going to put here maybe 13 instead, refresh and click, you're gonna have a smaller window, so the data looks like it's more spread out a little bit. Now, the next thing that I'm going to show you is how to create a gain node. And we are going to call this an envelope. For those of you who know about this ADSR envelopes, then we're going to do something like that. But no D or S. It's just going to have attack and release. And we're going to connect this node here to the audio context destination, so to the speakers. And this oscillator from here, we're going to connect it to the envelope instead. So oscillator to envelope, envelope to this destination. And here we also want to analyze the envelope. Now, if you save this and refresh and click, everything is going to be exactly the same. But we can change properties of this envelope. For example, we could go here and say the envelope gain and set it to 50% like this. Save, refresh, and when you click, you're going to see that this isn't spanning the whole space anymore because it has a lower amplitude, less volume, basically. I'll show you. Let's unmute this. Okay, and if we are going to say here 0.1, for example, you can hear less volume there. To make the beep, which is what the function says, we begin with 0, with a gain of 0, and then we are going to change this gain by using the linear ramp to value at time method. And we're going to say we want to ramp up to 100% or 1 at 0.1 seconds. And then we are going to call this again, and we will ramp to 0 again. But we are going to use a little bit bigger value here, 0.4. So this is going to be the duration of our beep. And we should stop also the oscillator when it ends. Now let's save, refresh, and when you click, that's the beep. Let's try with a different frequency, maybe 400 here. Let's visualize it with a larger window, maybe 2 to the 15. So that's how it looks like. And it's called linear ramp 2 because it's a linear change from 0 to 1 and back to 0. There are other functions you could use to change, like there is the exponential. Let's copy this one as well. But this won't work unless you put here a value that is not 0. It doesn't work with 0. But you could put, for example, 0.1 or something like that. And you can see the shape is different. And at the end, it drops like that because the 0.1 is not exactly 0. You could put 0.0001, but just not 0 there. You can play with these if you want, but I'm happy with the linear. And we are ready to make the sound for the intro, where we have that kind of counter 3, 2, 1, go happening. And we will make it be like a beep, 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 beep. So the frequency needs to be a parameter here instead of this 400 that we have now. And let's try to make that sequence of beeps here when clicking to test. So instead of beep there, we will create a new callback function like so. And we start with the beep of 400, like what we had before, and then use set timeout and give it a new callback function with another beep of 400 in it. And it's going to play after 1000 milliseconds or 1 second. And now let's copy this here. So this is beep, 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 and one more with a different frequency here, 700. Now let's save and refresh and click. Okay, you could see the last one there was darker because the frequency is higher, so it's more compressed. We are ready to make the engine noise, and we're going to start it also on click here. So let me comment out this testing. And the engine is going to be an object. We initialize it here like this. And let's define it at the top first and set it to null. It's going to be a global variable here. And we implement this engine class at the very end of this page here. Now, this class is going to have a constructor, and we begin by just copying everything we have inside of the beep for the engine for now. And now let's modify some things here. We don't need the frequency to be a parameter. We will just have a 200 fixed frequency to begin with. And we don't need these linear ramps. The sound will be constant, constantly purring somehow. We also don't need to stop the oscillator, so it just starts. Now let's set the gain here to 0.2 because we want this kind of rumble that isn't too loud. And this gain, we can now call it differently. So this is going to be master gain. It's going to control the volume of the entire effect here. Let's save and test to see if it works. Okay, it works. I'm muting it again. But it doesn't sound like an engine noise. And that's what we are going to do next. I'm going to go here and we will use modulation. This means that we are going to control this signal that we have now using the properties of another signal. I'll show you. We initialize a new oscillator. Let's call this LFO for low frequency oscillator. Like so, and set its frequency to something really low, maybe 30. It's not really, really low, but it's low compared to what frequencies we usually hear. We won't be hearing this. This will be used to modify the properties of the other oscillator. You'll see. And we'll also use another gain, and this is going to be a special one. Let's define it like before and set its gain value to 60. Now this is very strange, right? It's a very big value. Usually we have gains between 0 and 1 because that's 1 is 100%. But we are going to do something else with this signal. We are not going to listen to it. We are going to use it to modify this. So I'm going to connect now this LFO to mod, and let's connect mod to the oscillator frequency. So not to the destination, to the frequency here. And this oscillator frequency that is 200 is going to change by up to 60 now. Let's start this, save, refresh, click. And I still have it muted. You can't hear it yet, but you see that it's changing the frequency. Sometimes it's wider, sometimes it's narrower. And it's changing it at the rate defined by this here. So let's listen to it. Kind of like an engine noise, right? Let's play with these values a little bit. Maybe you understand a little better. Let's try a lower value here. And we get that. Let's try a larger value here. And we got that. But I like the previous values. And we want to control the volume and this frequency here somehow. So they should be attributes of this engine object that we are creating. And I'm just going to say this volume is equal to the master gain.gain. We get a reference to it. And the frequency will be the oscillator's frequency. And now if we are going to save and refresh, I'm going to click, the engine noise is going to come, and then I'm going to play in the console with those two properties, and let's see how it sounds like. Okay, so less volume now, and that was a higher frequency, like the car is going really fast, but maybe a bit too fast. So let's implement also some helper methods for this. And first one will set the volume, and we'll have a percent value here. So this volume value is that percent, like so. And let's have a method for setting the pitch as well. Maybe we want them not to match. And here the frequency, we have to use set value at time, like so. And maybe between 100 and 300 frequency. So let's say this plus 100 and at 0, so immediately when we call this method. And we can use these to change the properties of the sound depending on what the car is doing. So let's start to do the integration. We are going to copy from here this engine and this beep. So copying all of this code. And let's open the racing game project. And here inside of race HTML, we are going to create a new file for the sound. And I'm just going to duplicate this mini map here. And let's call it sound.js. And control clicking this will create the file. And now I'm going to paste everything that we wrote before. And it's going to stay pretty much the same, but we don't need this analyzer anymore. It's actually going to give an error if we keep it because it's not defined. It was only useful to debug and understand sound a little better. Now with this file in place here, we can go to race.js, and when that counter ends, like after 3, 2, 1 and go, so here we are going to give my car an engine. It's going to be a new engine defined like this. We could give all the cars engines, but that would just be crazy. And sure, you could do some kind of clever things here so that you could hear the cars that are behind, and if they're too far, you don't hear them. But I'm not gonna bother with that in this video. One engine is definitely enough. And let's make it work depending on the car's properties. So in the update method of the car, at the end here, we are going to say if the car has an engine, we are going to get a percent value of the speed. It's going to depend on the speed relative to the maximum speed, and absolute value because going in reverse will make the same noise, really. And here we set the volume of the engine to that percent. And I'm going to copy this for the pitch as well. Now let's open Race HTML. And if you don't click on the page or if you don't press any buttons, you're not going to hear anything. Because of that warning the audio context is generating there. But if you refresh and just hold the acceleration, you're going to hear the engine noise. Okay, the engine noise shouldn't be heard anymore when the car is damaged, so let's see what that is about. Here, when damaging the car, we can say if this damaged, we can set its speed to 0. This apparently isn't happening at the moment. It's just not updating anymore its movement if it's damaged. So setting the speed to 0 should make that noise disappear. Let's test. Okay, that's better. Let's have also the beeping noise in the beginning when the 3, 2, 1 is happening. So in race.js, here we have a beep of 400, and let's copy this here. And we may not hear the first few before we start to press the up arrow to accelerate, but I don't care. Really. You could have a start button and use that instead. And when you press the start button, you make the interaction that the audio context needs, but I'm just happy with this. Save and refresh. Okay, let's try refreshing again. I pressed quickly on this accelerate there in the beginning so that we hear more of the counter. Play with these things. Try to make something crazy happen. I am still going to add a couple of sounds, one for when damaging, a kind of explosion, and one for when ending the race, when passing the finish line. But I'm going to make these as a special short video for channel members. It's nothing too crazy, just I want something for them. And I will include the code in the GitHub version after this lesson.